Landing is one of the most demanding phases of flight. Unlike the cruise phase, it requires the pilot to manage a rapidly changing environment, adjusting for runway conditions, surrounding terrain, obstacles, weather, and aircraft configuration, all within a short window of time. Every landing must be planned thoroughly before the approach begins. The runway length and surface condition are the primary physical constraints of a landing. If the runway is short, the pilot must touch down no later than the touchdown zone, the marked area in the first third of the runway. Otherwise, the aircraft risks a runway overrun. During the rollout, the deceleration phase after touchdown, the pilot must apply braking carefully to avoid overheating the brakes, particularly after a series of rejected takeoffs or a long landing. Runway surface conditions, from dry to flooded, directly determine braking effectiveness. Terrain poses significant challenges at certain airports. Mountains can restrict the approach path and force the aircraft to turn finals very late, sometimes with a sharp bank. Some runways are built on slopes, uphill or downhill, which affects the approach angle and stopping distance. Obstacles such as buildings, hills, or other structures may require the pilot to bank hard very close to the threshold. At some airports, a missed approach, go around, is not possible due to terrain, meaning the pilot must land successfully from the first attempt. The landing sequence consists of several distinct phases. On final approach, the aircraft is lined up with the runway center line. As the aircraft approaches the runway surface, the pilot performs a flare, a gradual nose-up rotation to reduce the rate of descent and allow the main wheels to touch down smoothly. After touchdown, reverse thrust is applied to assist deceleration, together with wheel brakes. The aircraft then rolls out to a safe taxi speed and vacates the runway. One of the most critical pre-landing checks is confirming that the landing gear is fully extended and locked in position. If the gear fails to extend, either because it is jammed, seized, or the mechanism has failed, the crew must prepare for a belly landing. In this scenario, the runway is covered with a foam carpet by the airport fire service to reduce friction and the risk of sparks igniting fuel. In some emergency situations, the crew may need to jettison fuel before landing in order to reduce the aircraft's weight to within the maximum structural landing weight limit. Not all aircraft have fuel jettison capability. Smaller aircraft and some medium-range types must land overweight and accept the structural implications. During a high-density altitude takeoff or landing, such as at airports in mountainous regions, when the aircraft rotates for liftoff, the tail section may strike the runway and cause a tail strike. Similarly, at unusual airports such as Princess Juliana International Airport in St. Martin, aircraft pass extremely close over crowds of people who deliberately gather near the perimeter fence, attracted by the spectacular low approaches. Aircraft can also land on aircraft carriers, using an arrestor wire system that catches a tailhook, decelerating the aircraft extremely rapidly over a very short distance. Military pilots practice carrier landings extensively, as they are among the most technically demanding procedures in all of aviation.